have a topic known as micrometer screw gauge, and we'll be learning that how can we exactly find out the reading by using micrometer screw gauge. But first, let me tell you the main parts of micrometer screw gauge. These two are the jaws of the micrometer screw gauge. This scale, which is still, is known as main scale. As you can see, the readings are being shown on this. And the horizontal line on this main scale is known as datum line, while the scale which can move itself is known as circular scale. Now suppose I need to find out the diameter of this marble. I just have to place the marble between the jaws. I'll have to move the circular scale so that the micrometer is between the jaws and fixed. Now this is lock. I need to put the lock by moving the lock from this point to that point. And after that, I need to move this part 3 times and I'll be hearing 3 tick sounds. Then I need to measure the length or the diameter of this marble by using circular scale and main scale. So let's see how can we use the circular scale and main scale to find out the diameter of this marble or any other length. So now we need to talk about how can we exactly measure the reading of the micrometer screw gauge. I've already shown you how a micrometer screw gauge looks like and what are the main parts of the micrometer screw gauge like circular scale, main scale, datum line. But before going further and calculate or measure the length by using micrometer screw gauge, we need to know two important things. Number one, micrometer can measure length less than 2 centimeters. Number two, it has a precision of 0.01 millimeter. If you don't know about what precision is, let me tell you. Precision is something which any instrument can measure as least as possible. That means micrometer can measure lengths up to 0.01 millimeter as accurately as possible. Okay. Now, further ahead, luckily I have some diagrams which I've already drawn, so it will kill time. And through these diagrams, we can understand how to find out the reading using micrometer screw gauge. This is example number one. I have designed 3 examples just to make the concept more concrete. So in this example, we need to find out there is something between the jaws of the micrometer screw gauge. I have not shown the jaws because we are more concerned here about the reading. So I need to tell you guys how can you exactly read the scale to find out the reading of micrometer screw gauge. So I have designed my way, and the way is I have designed the measurement of micrometer screw gauge in 4 easy steps. And these 4 easy steps are: observe the last visible division on main scale. If you talk about main scale, this is main scale. And first, let me tell you how can you exactly read the main scale. There are 2 parts, the upper part and the lower part. You can see on the lower part, there are some divisions mentioned 0, 5, 10, 15. Whenever you are reading the lower part, you read the divisions by the factor of 1 millimeter, like 5, 6, 7, 8, 9, 10 millimeter. But whenever you are reading the upper part, you read the divisions by the factor of 0.5 millimeter. For example, 10, 10.5, 11, 11.5, 12, 12.5, and so on. So now step number 1 to measure the length using micrometer screw gauge is observe the last division on main scale. So which is the last division on main scale? 15, 15.5, 16, 16.5, 17, 17.5, 18. So 18 millimeter is the last visible division on main scale. So this is the answer of step number 1. Keep one thing in mind, micrometer measures in millimeter. Step number 2, which division of the circular scale, by the way, this is circular scale. Which division of the circular scale is coinciding with the datum line? The red line shown here, I have already told you this is the datum line. So which division of the circular scale is coinciding with the datum line? Division 10th. So this is step number 2. Division 10th is coinciding with the datum line. Step number 3, multiply that coincident division with precision. And this is a precision of micrometer screw gauge. And finally, step number 4 is add step number 1's answer and step number 3 answer. So this is the final answer of micrometer screw gauge. Whatever the thing is between the jaws, it has a length of 18.1 millimeter. Or if you convert it into centimeters by dividing it with 10, it is 1.81 millimeter. Here, it is clearly evident that normal ruler cannot measure length up to 1.81 millimeter, though it can measure length up to 1.8 millimeter. So you can see micrometer screw gauge is way more accurate as compared to the normal rulers. Now, let's have one more uh, example of micrometer screw gauge. This is example number 2. As I told you, I have designed 3 examples. So in this example, we will follow the same 4 steps. And these steps are: observe the last visible division on main scale. This time it is again 18. So 16, 17, 17.5, 18. 18 is the last visible division. Step number 2, observe which division of the circular scale is coinciding with the datum line. This time it's division number 25. Step number 3, multiply that coincident division with precision. And we know the precision of micrometer screw gauge is 0.01 millimeter. And step number 4, add step 1 and step 3. Or in centimeters, it can be written as 1.825 centimeters. So here it is also shown that normal ruler is beyond that accuracy. Let's have one more example to make this concept more concrete. Okay, so in this example, the last visible division on main scale is 677.58. 8 millimeter is the last visible division. Coincident division with the datum line. 45 this time. Multiply that coincident division with precision. And add step number 1 and 3. If it converted into centimeter, it will be 0.845 centimeter. So I hope the reading, the length measured by the micrometer screw gauge is now a concrete concept. And with the help of these three concepts or these three examples, we can easily measure any length by using micrometer screw gauge. Further, I have to tell you how can you exactly find out the zero error, and when you found out the zero error, how can you make your final reading as accurate as possible by finding out the zero error. So in order to find out the zero error of micrometer screw gauge, one thing you need to make sure that the jaws of the micrometer screw gauge are completely closed. And in this condition, observe if the datum line is coinciding with the zero of the circular scale. In this case, if you can observe, the datum line is in line with the zero of the circular scale. So we have no zero error. Okay. So that means if a zero error is present, micrometer's screw gauge datum line will not be coinciding with the zero of the circular scale. It can be above the zero of the circular scale, or the datum line will be below the zero of the circular scale. So here in this case, as you can see, the datum line is below the zero of the circular scale. This is datum line and this is circular scale 0. So this error is known as the negative zero error. While if the datum line is above the zero of the circular scale, that type of error will be known as positive zero error. Here the datum line is above the zero of the circular scale. So now we need to talk about how can we exactly measure the zero error of micrometer screw gauge. So there is a simple condition. If you want to find out the zero error of micrometer screw gauge, first you need to make sure that the micrometer screw gauge is completely closed. Means both jaws of micrometer screw gauge should be joining with each other. Okay. And then you will observe the main scale's datum line and circular scale 0. For example, if the main scale of the circular scale is coinciding with the datum line when the jaws of the micrometer screw gauge is completely closed. In that way, there is no zero error. And this micrometer screw gauge will show exact reading because it does not have any zero error. Which means if a micrometer screw gauge has a zero error, that means both zero of the circular scale and datum line will not be coinciding with each other when micrometer screw gauge is completely closed. So there can be two different situations. Situation number one is when the zero of the micrometer screw gauge is below the datum line. This error is known as positive zero error. So when the jaws of the micrometer screw gauge are completely closed, and in this situation, the zero of the circular scale is below the datum line, this type of error is called positive zero error. Now we need to find out the exact value of positive zero error. And we need to follow the same 4 steps which I have already taught you, that in order to find out the reading of the micrometer screw gauge. So step number 1 is observe the last visible division on main scale. Here 0, 1, 1.5. So 1.5 is the last visible division on main scale. Step number 2, observe the coincident division. Here the coincident division is 3. multiply that coincident division with precision, and add step number 1 and step number 4, sorry, 3. Since this is a positive zero error, so I will put a plus sign here. So plus 1.53 millimeter is this positive zero error in this micrometer screw gauge. What does it mean? That means if you use this micrometer screw gauge to find out any length, this much amount of length will be absurdly added into your final reading. Now, for example, we are talking about this micrometer screw gauge, which has a positive zero error of 1.53 millimeter. That means this length is already adding or is already being added with plus 1.53 millimeter of positive zero error. So if I want to find out the exact length, what do I have to do? I just have to minus or subtract this value from the final reading. And in that way, I can find out exactly the value or by using micrometer screw gauge. So the final answer is 6.92 millimeter. So this is the final answer, and we have minimized the micrometer screw gauge effect or zero error of the micrometer screw gauge. So this 6.92 millimeter is a reading which is pure from any zero error. This was the positive zero error. Now, if we talk about the second classification or type of the zero error, which is negative zero error. So let's have an example. In this, if you can observe, the zero of the circular scale is above the datum line. And if the zero of the circular scale is above the datum line, this type of error is called negative zero error. So in order to find out the exact value of negative zero error, we have to follow the same 4 steps. Step number 1, last visible division on main scale, which is 0. Step number 2, coincident division with the datum line. Here it is 43. Step number 3, multiply coincident division with precision. So the final answer is add step number 1 and step number 3. So this is the final negative zero error. And I have put the negative sign just to show it is a negative zero error. So if any micrometer screw gauge has this negative zero error, that means if you use that micrometer screw gauge to find out the length of anything, it will be shown an incorrect reading because 0.43 millimeter is absurdly being subtracted from the final reading. So let's consider if this micrometer screw gauge has a zero error of 0.43 millimeter, negative zero error. And this is the reading along with the zero error, which is not an exact reading. So if you want to make sure that this reading is an exact reading, what do you have to do? You just have to add this amount of reading into the final reading. So the final answer will be 18.68 millimeter. 18.68 millimeter is an exact reading without any negative zero error. So in a general overview, if I tell you if the datum line is above the zero of the circular scale, it is a positive zero error. And if you calculate the positive zero error, you just subtract this amount of error from the final reading. And if your micrometer screw gauge has a negative zero error, which means the datum line will be below the zero of the circular scale. And if you find out the reading of the negative zero error, you just have to add that reading into the final reading in order to minimize the effect of zero error. So I hope each and everything is clear. I hope you are clear with the concept. If you are, then don't forget to like and subscribe and push a bell icon so that you don't have to miss any future video and lectures. Thank you very much.